In this video, I will help you to get started with the Diabetics ColdStream platform. We'll submit a generative design case for a wafer table, a liquid-cooled case. Let's enter the project. We'll start with creating a new case. You click the Add Case button and you give it a name. We will optimize this case for thermal uniformity, so let's call it thermal uniformity optimization. You select the case type, and here you need to choose either you want to run a simulation or you want to create a design. In this case, we want to create a design, and we add a case. Then you're coming to the case summary where you can start the setup. Let's click the Start Setup button, where you can start with uploading the step file. I have prepared a step file in my CAD environment already, which contains a solid region, a fluid region, and a design region. Beside these regions, you also have some surfaces, which define the inlet, the outlet, and a heated surface. Let's have a look now that the step file is loaded. You can see a solid region and a fluid region. Once the step file is loaded, you can start defining the boundary conditions. Let's start with the first region, which is the solid region. You can give that a name. Let's call it a wafer table. And you can apply a material, which will be aluminum, silicium, then magnesium. You can select the material and you can add a few more things. You can assign radiation, or you can define a volumetric heat source. Beside that, you can also add design targets or design constraints to this. If you have a look to your region overview, you can see that there is one boundary added to the wafer table. Let's click on it and let's visualize it. It's the heated wall on the wafer table. Here we will apply a heat load which equals 10 watt. We want to minimize the heat spread over this heated wall. That's our design target. You can add a design target on the bottom of the boundary settings simply by clicking Add Target and selecting what you want to do. As I said, we want to minimize the spread of the temperature. Then we can jump to the second region, which is the fluid region. Select again the type of region, you give it a name, and you select the material, which will be water in this case. Again, you can select radiation or buoyancy if necessary. Then you can also select the turbulence model. There are a variety of turbulence models available. In this case, we will go for K omega SST. And again, you can see that there are some boundaries added to the fluid region. Let's have a look. This one will be the inlet, so we call it fixed flow rate inlet, which has a temperature of 273 Kelvin, and there is a mass flow rate of 0.015 kilograms per second. Then you also have the outlet, which is just a pressure outlet. Then you can see that there is also a sub-region added to the fluid. Let's have a look. This is the design region. In this region, the generative design tool will be able to place structures. Again, you need to define the type, which is in this case design. You can give it a name as well. You can select which material will be added, which is again the same material as the wafer table. And you can select the manufacturing type, which will be 3D printing. Last but not least, we will also want to set a constraint on the pressure loss. We don't want the pressure loss to exceed 70 kilopascal. So then you go again to the inlet boundary, you add a target, which is pressure loss, and we set it to 70 kilopascal. Once that is done, you have defined all your boundaries, and we are ready to validate the case. When you click the validate button, the Diabetics platform will check if all the boundaries are filled in a correct way, and if it's okay, he will indicate that you are ready to submit. Now you can click the submit button. You can select which type of case you want to do. And you can submit a case. In this video, we covered how to submit a generative design case on a liquid-cooled case. If you want to know more about certain features or you want to have more in-depth information, have a look on our documentation page.